everybody, it's Mrs. Pound, and I am back with the last section for Chapter 32 on electrostatics. Our objectives for today's video are to distinguish between a conductor and an insulator, describe how an insulator can be charged by friction, describe how a conductor can be charged by contact, describe how a conductor can be charged without contact, and describe how an insulator can be charged by charge polarization. So the first thing I want to talk about are conductors and insulators, and this should be review. A conductor is a material composed of atoms with loose outer electrons that are free to move about in the material. And a good example of this is something like copper. Usually our metals are good conductors of electricity. An insulator, on the other hand, is a material composed of atoms in which the electrons are tightly bound and remain with particular atoms. Some examples of good insulators are glass and rubber. That's why electrical wires are wrapped in rubber generally. There are also semiconductors. These are materials that can be made to behave sometimes as insulators and sometimes as conductors. And an example is silicon, which is in transistors. This is what really makes us able to build computers too. Computers tend to make use of semiconductors. And then one you probably have not heard of is a superconductor. This is a conductor with zero resistance to flow of charge. And this is kind of an extreme case in that there are some materials that behave as superconductors at very low temperatures. And here in the background, this is a material that is made of carbon, sulfur, and hydrogen between two diamonds under very high pressure that will also act as a superconductor. Now, we can charge objects, and some things we can charge by friction and contact. So an object is charged by friction when one material rubs against another. Okay? Some examples are when you stroke a cat's fur, comb your hair, scuff your shoes, and touch a doorknob. When things become staticky, okay? Your clothes coming out of the dryer. Electrons flow from cat fur to a rubber rod by making the rod negatively charged. And I'll be doing this in class. And so I have animal fur that I will rub on a rubber rod to make it negatively charged. In class, I will also charge an acrylic rod by rubbing it with a silk cloth to make it positively charged. Now, an object is charged by contact when electrons are transferred from one material to another by touching. So down here I have a diagram, and you're probably wondering what this diagram is. And so to show that you're listening, I want you to label some things. So these rectangles with the negative charge in them, label that a rod. Okay, maybe draw an arrow to it and label it rod. And the circles, I've shown this in class and I'll be using these again. These are pith balls. So draw an arrow to it and write pith ball. P-I-T-H. Okay, pith ball. So what I can do is I can negatively charge a rubber rod by rubbing it with animal fur, and I can touch a pith ball with it. And what that does is it transfers the electrons from the rubber rod to the pith ball. So go ahead and also draw an arrow from the rod to the pith ball showing the movement of that charge. And what then happens is I have a negatively charged rod, I have a negatively charged pith ball, and remember, like charges repel, and so that pith ball should move away from my rubber rod then. So when we charge things by contact, we transfer the charge from one object to the other, and they have the same charge. So charging by contact causes them to have the same charge. I can also charge by induction. When something is induced, this is a term applied to electric charge that has been redistributed on an object because of the presence of a charged object nearby. The key here is they do not touch, okay? Not like the contact in the previous example. They do not touch here. And induction is the charging of an object without direct contact. A key here also is to understand what grounding is. Grounding is allowing charges to move freely along a connection between a conductor and the ground. So electrons flow from the ground to the object or from the object onto the ground. And maybe you have seen grounding wires before. That is what is happening there. It's so that you don't maybe get shocked by your appliances. So there is a grounding wire that takes and runs the electric charge from the appliance to the ground. Now, how this works, and you don't have to label the rod and the pith ball here like you did in the other diagram because you shouldn't understand what those are. So I have my negatively charged rubber rod that I charged with animal fur, and I bring it near the pith ball. Now the pith ball is neutral, so it has a balance of positive and negative charges in it right now. And what happens is when I bring the rubber rod towards it, the positive charges tend to migrate towards the rubber rod, and the negative charges are repelled, so they go to the other side of the pith ball. Okay? Now, what you need to label is this strange thing that I put in here is actually your finger. Okay? So what you do when you charge by induction is you bring the rubber rod close to it, not letting it touch, but you touch the pith ball with your finger. Okay, so I'll know that you're listening if you have the finger labeled there. And what that does is this arrow is here because what it does is the electrons are now grounded. They have a path to the ground, and they move from the pith ball through your finger to the ground. Okay, so the electrons leaving the positive charge. Now that rubber rod will attract the pith ball because they have opposite charges. So when we charge by induction, we end up with an object that has the opposite charge as the object we use to charge it. Okay, so the pith ball has the opposite charge of the rod, where if it was contact, they would have the same charge and they would repel. And our final topic for this chapter is charge polarization. When something is electrically polarized, this is a term applied to an atom or molecule in which the charges are aligned so that one side is slightly more negative than the other side. Electrical polarization has nothing to do with the vibration of an atom. It has everything to do with the location of the charges and how they're distributed. Now, the reason I have balloons in the background is because a charged balloon will stick to a wall because induced opposite charges in the wall are closer than other charges. So I might rub a balloon against my head and charge it, and then I can stick it to the wall. Now, the charges don't freely flow. They don't, like with the friction or the contact or the induced charge, they don't become necessarily positively or negatively charged that way. It's just the charges kind of migrate. They stay in the wall, but they migrate. And so if my balloon is negatively charged, the positive charges come closer to the balloon and the negative charges are repelled and move away from the balloon, so the balloon will stick to the wall. Some molecules also have an electric dipole. An electric dipole is permanent separation of charge distribution in some molecules in two regions. And an example is water. We call these molecules polar molecules, if you'll remember from chemistry or physical science. And so in water, the oxygen end of the atom tends to be negative, and the hydrogen end tends to be positive. And so what we'll see in class is I will charge a rod, and we can actually get the water stream to be attracted to the rod, because if I have a negatively charged rod, the positive part of the water will be attracted to it. If I have a positively charged rod, the negative part will be attracted. So we can actually get the water to bend as it's being poured toward the rod because it is a polar molecule. So that would be a good test to see if something is a liquid in particular is polar or nonpolar. So our objectives today were to distinguish between a conductor and an insulator, to describe how an insulator can be charged by friction, describe how a conductor can be charged by contact, describe how a conductor can be charged without contact, and describe how an insulator can be charged by charge polarization. So, 5 questions, and you have everything you need to start studying for the test.